Hey, Sui On Campus. I'm Sam. I'm the co-founder and CTO of Meston Labs and the creator of the Move programming language. I'm really excited to be invited to your event. I'm sorry that I couldn't make it live this time, but hopefully next time, if there's an evening event, it'll work out at a slightly better time, and I'll get to hang out with you all. Um, so the thing I wanted to talk to you about today, Thompson asked me to prepare a talk on a couple different topics: mastering move, innovations, best practices, and future directions. So I'll take 10 or 15 minutes or so and talk to you all a little bit about each of these things. So this is work that I'm doing with the Move Core and Move Innovation teams as Miston, and as well as with the Sui developer community, who give us great feedback that help us improve the language and inform all of the tech work that we do. So yeah, let's maybe start with the innovations part. I'll talk to you a little bit about why Move exists and what the core ideas behind it are. So I think really the key thing I want to emphasize in terms of motivation for Move is that I think smart contract safety is an existential threat to broader crypto adoption. If you look at the state of smart contract safety, it's sort of a silent crisis that we just deal with. On the left here is a list of the top 10 biggest hacks in crypto based on this rec.news site. And the amounts here are just eye-popping, hundreds of millions of dollars and, almost 200 even for the smallest one. We're at a point where these just massive hacks, losses of hundreds of millions or more, are routine. And this just isn't the case elsewhere in software, and I don't think it's something that's going to be sustainable. And I think this is especially true when you think about who are early crypto devs. They're folks who are hardcore, they really understand the underlying chain, they're very security conscious, they care a lot about smart contracts and sort of the craft. And I think if you add more devs to crypto, they're going to be more focused on applications, on bringing people in, just on building a product. They won't care as much about the security stuff or the low-level details. So this situation will only get worse. We already have sort of the best, most security-conscious devs, and this is the result that we get. So when I think about how can we grow the crypto developer community, how can we push all this stuff closer to mainstream adoption, I think the only way is to have safer smart contract languages that prevent a bunch of this stuff by construction. So not only can the devs of today be safer, but we can onboard new folks that want to make things worse. So really, that's one of the big motivations of Move. We see the current crisis of today, and let's see what we can do to prevent a lot of this stuff by construction. So there are three key Move design principles. So the first one, directly motivated by what I was just talking about: secure by default. If we're going to add a feature, if we're going to if we're going to make a change, we want to make sure that if there are safety issues, either they just don't exist at all, the feature is implemented in a way that doesn't have them, or it'll be very clear what the potential issues are, and we'll have tools and linters and other mechanisms to try to prevent them. And so in particular, we're really inspired. We look a lot at the EVM and its Solana contracts and see what kind of safety issues arise there, things like reentrancy, things like missing permission checks, and we strive to just keep those out altogether. The second principle is expressive by nature. Just because things are going to be safe doesn't mean we want to hamstring developers. We want to make sure that you can write any smart contract you can imagine, and that you can do this with really minimal code. Something we talk about a lot is how can we make the gap between thought and code as small as possible. You should be able to have an idea or describe something that just translates very directly into what the actual Move code would look like. This makes it quicker to write things and makes it easy for others to understand code, and makes it harder to introduce mistakes. And then finally, intuitive for all. So this is both from a learning perspective. We want it to be easy for existing Web3 devs to pick up. We want it to be easy for Web2 devs coming into the space to pick up, because that's going to be one of the biggest ways that the developer community grows. And just as importantly as learning, we want it to be the case that if you have a Move package, it's really easy to just slot it in and use it in an existing app. It should feel this just as easy as, I want to use this new API or add this new tool. It's just, it's a Move-powered API or tool. It's no different than, hitting my favorite HTTP web endpoint or something like that. And so let's get a little bit more concrete into how we're trying to achieve these goals. So the key thing that we do is we look at smart contracts and we think about, what are these things? What kind of programs are these? What are they trying to do? And the key concepts that matter a lot in smart contracts and that don't matter in existing languages is that everything is about assets and is about this logic of exchange and authentication. And so in Move, we have this really explicit representation of assets in the form of these typed objects, and then we make it really easy to express logic of exchange and authentication. So like, let's look at some example code just to dig into this idea a bit. If you look at this function here, it says it's a function buy, it takes a coin as an input, and it returns a card title. And so what this code is saying is it's making an offer. It's saying, if you give me a coin, I'll give you back a card title. Okay, this is very direct. You can similarly express the idea of borrowing or a temporary exchange of ownership. So let's look at the second function. It says register, and it takes a reference to a card title. That's what this ampersand means. And it takes a coin and returns a card registration. So what this code is saying is, if you show me your title, I'll give it back when I'm done. I'm not going to take ownership of it. I just need to see it and pay me a fee. That part's an ownership transfer. I'll keep it. Then I'll give you back a card registration. And so this too is a very natural thing that comes up a lot. Sometimes you're generally exchanging, you're giving something to someone. Sometimes you're just showing it, and it's right there in the type system. You don't have to implement this yourself. And the other thing that's important here is all these different types: coins, card titles, card registrations. Of course, they're not going to be built in. We want to let the user define them and give them whatever shape they want, and put whatever fields they want inside. So here it's just showing like a coin is just a wrapper around an integer that's going to have special rules for how value can change. And a card title is just going to be a wrapper around things like the VIN number of the car and whatever other attributes you might want. And then move at the type system level gives you a lot of protections that makes the behavior of these objects sane. So there are three key things that it's protecting against. So one is that you can't duplicate objects. So for a coin, in standard code, in a different language, you might write something like, oh, I'm going to take a reference to the coin, let x equals ampersand c, and then I'm going to dereference it, let y equals star x. Well, in Move, we don't want to let you do that because, this is a coin, it has value. We shouldn't just be able to copy it around like I could an integer or a string, because that would defeat the purpose of having a coin. So the type system is going to give you this protection. Additionally, you get protection against double spending. If I get a coin as an argument and I call pay of C, C is going to get moved into that call to pay, and that's where the name of the language comes from. If you try to call pay of C again, you'll get an error that says, hey, C has already been used, you can't do that. So this too is very important for the typed object representation that we want. When you transfer ownership from one procedure to another, the object doesn't exist in two places at once. It's always very clear where it is. And then finally, protections against accidental destruction. So if you take a coin as input and then you just return and you forget to do anything with it, that's not good, because you have something of value and now you've just dropped it on the floor. We don't want that to happen. We want to make sure that anytime you have something of value like a coin, it gets moved into a place where it's going to be safe. And so basically these three guarantees together are trying to ensure that digital objects behave like physical ones. And this is also what helps us close this gap between thought and code. We're all very familiar with how things work in the physical world, sort of things like, hand me this apple and I'll give you this orange. And we want those thoughts that you have to translate very, very directly into Move code and then have things work the way that you expect. So that's sort of the core ideas, like why we decided to create Move, the motivation, and some of the key concepts. Let me go a little bit deeper into Move today and some of the best practices that we want folks to follow. So there are three core technical elements of Move that I think the Move programmer of today who's working on a sophisticated package or smart contract or app is going to encounter. So one is the object data model. We talked about that one a little bit. Objects are the building blocks for smart contracts and apps. You work with them in your Move code. You'll show them to your users. They're in a wallet. You'll see them in explorers. They're sort of everywhere. So it's the way we represent coins, NFTs, any assets, just the thing that ties everything together. There's programmable transaction blocks, or PTBs for short. And these are a form of dynamic and atomic code composability, where you're on the client side, you can take a bunch of different Move calls and you just glue them together in a nice and convenient way. And then finally, there's dynamic fields, which lets you to create hierarchies of objects. Like you have a hero and they have an inventory that has a sword and a potion inside, and the sword itself could have a sheath, and you can just glue all these things together in a nice and flexible way. So I don't have time today to go through all of these, but let me go a little bit deeper on programmable transaction blocks specifically, because this is a feature that I think is particularly interesting and is definitely a favorite of programmers on Sui. So the way a PTB works is that And so a transaction isn't just a call to a single smart contract function. It can actually contain over 1,000 different calls. And each of these calls takes objects as input, and it can also return objects. And you can take objects from an earlier call and pipe them into an input as a later call and sort of glue them together in this nice Lego blocky kind of way. So this lets you basic batching. You want to pay a bunch of different people at once. You want to mint several NFTs at once. But then it also lets you do heterogeneous composition where you're calling several different functions and sort of gluing these objects, object outputs into object inputs, as I described before. And then you can build these things on the client side in TypeScript and Rust and whatever your favorite language is. So here's a little bit of example code from Scallop, which is a popular lending protocol in Sui, where each of these calls here is actually gradually building up a PTB. So first, we're doing open obligation entry, that's making one move call. We call open obligation, that's returning 3 things. Each of these 3 things is actually an object, an obligation key object, and a hot potato. And then we go ahead and add additional, we take those objects and we pass them into another function. And so we build up this PTB, and then at the end we say sign and send TX block. This is just built up this whole PTB in one step, and then it sends it. We're kind of writing move code, but we're doing it on the front end side. And so generalizing a little bit, like this is what I think PTBs let you do. They're a solution to what I call the Expedia problem, where you have dynamic and permissionless atomic composition. So maybe I want to buy a Chicago to New York train ticket and a New York hotel and a museum tour. But the thing I want is that I only want to be able to get the hotel and the tour if I can get the train ticket, because otherwise, of course, I can't get to New York and I won't be able to get those things. So what are the different elements you would need for this to succeed? You have vendors like the person who's selling the train tickets, the person who's selling the hotels, and the person who's selling the museum tour. And these folks shouldn't need to integrate with each other or be aware of each other or implement any common standards. And then you have an aggregator who's like the Expedia. They should be able to bundle any different combination of vendors for each of these, and they should be able to pick them on the fly based on the best prices or on the customer's preferences. And so in this sort of analogy, the vendor is a move package that's expressing an offer to be able to do something, and then the aggregator is a PTB-powered app, which is choosing on the fly dynamically which of the different move packages am I going to call and stitch together here. And so nobody's selling hotel rooms in New York, train tickets on Sui quite yet, but what folks are doing that looks like this is these very sophisticated PTB-powered smart routers. So things like Hop Aggregator, Aftermath Aggregator, there are many different ones that have a pretty brutal competition these days in terms of who's the most efficient. So here's just a small example of a PTB from one of these. So here someone's swapping Sui for the Scallop tokens, and they build up a PTB that's touching 4 different protocols. None of these protocols explicitly integrate with each other or have common interfaces. Nobody has to publish code that's doing this particular path. They just, from the client side, decide these are the protocols I want to hit to get the best deal at this moment, and I'll stitch it together in a PTB and then send it. And this is all for a gas fee of less than a cent. And so the person who's sending this example is saying, you wouldn't be able to do this directly on EVM with a complicated proxy contract. It's really PTBs that are enabling this. So today PTBs are a superpower for Sui DeFi builders, but I think in the future there'll be lots of apps that follow this vendor aggregator pattern as you get more on-chain assets to do really interesting things and build these rich experiences. So let me conclude by talking a little bit about future directions. So first, on sort of the micro short-term level, the next 2 Sui releases that are coming have some really major move advances that I think developers are going to be excited about. So first of all, we have safe native randomness. We've been testing this in testnet for quite a while now. It's been a long time coming, but we're finally ready to ship to mainnet. So this thing is quite simple. You can now take a random object as an input to your transactions, and then you can get a random U64 or random strings, any of these random types that you might want. And then you can use that you can put this thing inside to create an NFT. So this is really useful for gaming. It's good for loot boxes. It's good for NFTs, lotteries, anything that requires randomness and doesn't want to trust an external party. Now you can just bootstrap on the trust you have in the Sui validators. And then second, this is less product and more developer facing. You have enums and pattern matching. This one we've also been testing in testnet for quite some time. But this lets you create much richer object types that can have many different forms and different fields of each. and then do nice pattern matching against them to pull out different bits. And it's especially useful, we think, for object upgradability. And then on the sort of longer time horizon, we think Move is the best smart contract language, but we're very cognizant that smart contracts are only one part of an app. The rule of thumb we like to use is maybe the app is 5% smart contracts and 95% front end and other stuff. And so if you're building an app, like reading the state that's managed by Move is something you're going to do a lot more often than sending transactions. And sending transactions, you're going to do even an order of magnitude more often than writing new smart contracts. And so yeah, you're just going to have a lot more front end and back end code than smart contract code. So of course we care about Move. We're going to keep pushing the boundaries there. But we think a lot about how can we evolve Move with these win-win abstractions that help both the smart contract developer and the app developer to write their code more quickly, to write safer code, and just to generally work better together. And so finally, this has been mostly about technical stuff, but by far the most important thing for Sui is to grow the developer community. So I'm showing two charts from the Electric Capital developer report here. Sui is on the left, and then crypto as a whole is on the right. So Sui is doing well in this area. We have the largest Move dev ecosystem. We have over 1,100 monthly active devs. But Sui's total is only 4.5% of all crypto devs, and the crypto dev community itself is still also very tiny. 26,000 people versus say 16 million when we talk about web devs. So one reason I'm really excited about Sui On Campus is you all have a large and dynamic group, like awesome developers, a lot of energy. We need your help in growing the Sui community, growing the Move community. And so I'm really happy to begin the opportunity to speak with you all today. If you have questions, you know where to find me on Twitter and elsewhere. And thanks so much for the invitation. I hope to be back in a future event as well.